Hello, welcome to video 11A. I'm Mr. Miller, and you must be an algebra student. Today we're going to talk about types of patterns, and we want to learn how to recognize linear, quadratic, and exponential patterns. All right, here we go. Let's look at some examples. So our mission here is simply to continue these following patterns. So the way I usually do it is start by seeing how each pattern is changing. How are we going from one term to the next? And see if we can recognize something there. So here I'm going to do 16 minus 19, and I'll get negative 3. That's how much this has changed. It's went down by 3. I'm going to check the difference between 13 and 16. 13 minus 16 is negative 3. I see it went down by 3 again, and it's doing it here. That's a clue to this pattern. This sequence is going down by 3 each time. So 10 minus 3 would be 7. 7 minus 3 would be 4, and 4 minus 3 would be 1, and we finished that one. All right, let's take a look at this one. I'm going to try the same thing. 10 minus 5 is 5. 10 minus 20 is 10. Something's going on here. It's not the same pattern as last time. And 40 minus 20 is 20. Instead of adding or subtracting something, I think this time might be a case where we're multiplying. So my first attempt is to see if we're adding or subtracting something. Maybe my second try is to see if we're multiplying by something. And sure enough, 5 times 2 is 10. 10 times 2 is 20. And 20 times 2 is 40. So that's consistent here. We're multiplying by 2. So 40 times 2 is 80. 80 times 2 is 160. And 160 times 2 is 320. All right, look at this guy. It's just negative 5s. This is kind of a constant kind of pattern. It's always negative 5. So this is the easiest one. We're just going to keep going at negative 5. All right, the last one here is kind of different. I'm going to find the differences. 13 minus 7 is 6. 23 minus 13 is 10. 37 minus 23 is 14. So it's not like the first one where it's going up or down by the same amount, but there is a pattern to the differences. I see that they're changing by a steady amount. These, by the way, are called the first differences, and if we find the differences of them, we get 10 minus 6 is 4, 14 minus 10 is 4. If those are constant, this is called a quadratic pattern. All right, so I got to follow the pattern of the differences. This is 6, this is 10, this is 14. The next difference is going to be 18. So 37 plus 18 is 55. The next difference is going to be 22. 55 plus 22 is 77. And the next difference is going to be 26. So that'd be 83, I think 103 if we added 26. So we see that there's a pattern to the differences. They're changing by a steady amount. That's a sign of quadratic. And we'll talk about that in a second here. All right, so these are kind of the 4 basic patterns we're going to consider. All right, for these, we want to continue them and we want to plot them. So we're going to start with the constant sequence. And all the terms are the same, so that's pretty easy to fill out. And now we're going to graph this. Well, this first 7, that's the first term. So on the x-axis, we have the number of the term, and on the y-axis, we're going to plot the value of the term. So the first term is a 7, so when x equals 1, I'm going to put a dot at 7. The second term, this is the second one here, is 7, 2. We'll put a dot there. The third term is 7. In fact, the fourth term is 7. The fifth term is 7. The sixth term is 7, etc. This is how we can recognize a constant pattern. When we graph it, it's a horizontal line. Okay. This is a linear sequence. So this one, let's see what it's changing by. When I do 7.5 minus 8, that's minus 0.5 or minus a half. 7 minus 0.5 is minus a half. This is going down by a half. So this would be 6.5. 6, 5.5, and 5. All right, the first term is 8, so when x is 1, I'm going to apply 8. The second term is 7.5, so when x is 2, I'm going to apply 7.5, which is about there. The third term is 7, sorry, so I'm going to apply it there. It's going down by a half each time. So when I plot these, what we get is a line. It's a linear pattern. It's changing at a constant rate. That's how we can tell it's a linear pattern. It's going down by a half each time. Okay, well, let's move on to quadratic. All right, these are a little crazy. So I'm going to find the differences here. 6 minus 1 is 5. 9 minus 6 is 3. 10 minus 9 is 1. Look at the pattern here. The differences are going down by 2. The next difference is going to be negative 1. And the next one after that is going to be negative 3. So 10 minus 1 is 9. 9 minus 3 is 6. So I have to work out the pattern and the differences before I can work out the sequence. All right, let's plot them. So the first term is 1. So when x equals 1, the value of the first term is 1. When x equals 2, it's 6. When x equals 3, it's 9. At 4, it's 10. The fifth term is 9. And the next term is 6. I'm going to throw in one more. If we had found one more term, it would have been 1 again. And what I want to illustrate is that a quadratic pattern has a kind of U shape. It'll either be an upside down U or an upside U like this. Okay, well, you'll learn a lot more about those in advanced algebra probably, but these U-shaped kind of graphs. But for now, we just want to recognize when a pattern is quadratic. Okay, this one is exponential sequence. That's when we're multiplying or dividing by something. It's a little hard to see here maybe, but we're actually multiplying by 3. When you take 1/9 and multiply it by 3, you get 1/3. When you take 1/3 and multiply it by 3, you get 1. And 1 times 3 is 3. And when we multiply that by 3, we get 9. So the first term is 1/9. That's really small. I can only approximate it here. The second term is a third, not much bigger. It's still less than half. The third term is 1. The fourth term is 3. And the fifth term is 9. This is exponential growth. It kind of grows quickly. So an exponential graph kind of has a shape like this. It starts out pretty level, but then it starts increasing rapidly. Or sometimes it goes the other way around. It starts really high and comes down and kind of levels out like this. That's an exponential graph. Linear, exponential, quadratic functions are families of functions that we study sophomore and freshman year. And so you'll see a lot more of these. Okay, this is the last example here. Sometimes we'll be given a table. We want to know what kind of pattern it is. I mean, maybe we could plot these. Maybe you could plot them on decimals or something, kind of look at the shape and find out what kind of pattern it is. But we want to look at how the y variables are changing. In all of these, the x variables are kind of going up by 1. It's changing at a steady rate. What determines the type of pattern is how the y variable is changing. On this one, I see we're multiplying by 4 times 4 times 4, and multiplying by 4 again. When we're multiplying or dividing by a number, that's an example of an exponential graph. Okay, let's look at this one. This is going down by 13. And this is going down by 13. And that's going down by 13. And the last one, we're subtracting 13. When we keep adding or subtracting a number, when it's changing at a constant rate, that is an example of an linear pattern. Okay, let's look at this one. This changed by 2, this changed by 4, this changed by 6, and this changed by 8. All right, let's look at the second differences. 2, 2, 2. Wow, when the second differences are constant, and the first differences are changing at a steady rate, this is a quadratic pattern. Okay, it's time for a journal assignment. I hope that introduction helped. For this, continue the sequences and let us know what type of sequence it is. Best of luck to you.